Hello viewers, I suppose all of you are fine and doing good with your studies. As the examinations are approaching, I think the tension is also rising within you. But don't worry, if you have understood the concepts very well, if there is no doubt or ambiguity between your concepts and your understanding, I suppose nothing shall worry you. Well, whatever video I have uploaded, I suppose you have gone through it very well and done the problems as I have instructed. Anyway, today I have taken up the topic of continuity, the very first topic of calculus, the differential calculus, that is continuity. Now, usually people have lot of confusions regarding continuity, but if you understand the concepts very clearly, I think there should not be any doubts or ambiguity or confusions. So let us understand the concept with the help of a function and its graph. So if I take a function, say fx, which is defined in this way, fx is equal to 1 when x is less than 0 and equal to 2 when x is greater than equal to 0. Now if I draw the graph of this function, let us take this y-axis, this is x-axis, this is 0, this is y. So when x values are less than 0, values of x less than 0 means the negative, then y is 1. Let this be 1, let this be 2. And when the values of x are less than 0 means the negative values, this is 1. Then the values of y are 1. And when the values of x are greater than 0, this side, that means this side 1, 2, 3, this side it is -1, -2 and so on. So when it is values are more than 0, the values are 2. And at 0 also it is 2. Now this is the graph of this function. So what we notice, when we have to draw the graph, could we draw the graph without lifting our pen? Once we had to draw this way, then we had to come back, lift our pen and we had to come this way. This is where the continuity concept is understood. Here the graph of the function is not continuous. Continuous means like this, means I am not lifting the pen. The pen goes like this, the continuous graph I could draw. But here I have to lift. So all continuous functions will have a continuous graph. There is no stop, or we have to not lift the pen and move to other side. Well, this was the graphical understanding of continuity. We shall understand the mathematical concept with the help of another example. Let us see. Now we have understood the concept of continuity in the graphical form. Now it is not always possible that we draw the graph and then we see whether the function has a continuous graph or not. So we need to understand the mathematical meaning behind a function to be continuous at a particular point or a particular interval, and how it can be declared that it is a continuous function or it is not a continuous or a discontinuous function. When the function is not continuous, we say it is discontinuous. Now, whichever function is continuous at particular point, we see the continuity at a point. Let us understand first of all what is the continuity at particular point. Suppose a function's graph is drawn and here there is a break where it is discontinuous, then the graph maybe begins here. So there is a discontinuity. Now in that case, how to check? First of all, the first criteria for a function to be continuous is the function should be defined. If the function is not defined, means if the function gives some indefinite value, infinity, then the function at once can be declared that it is discontinuous at that point. If it is giving a finite value, then what? Then we need to find the limit of the function at that particular point. We find the limit of the function, we find out the functional value of the function at that particular point, and then we compare. if the functional value and the limit of the function are both same or equal, then the function is continuous at that point. Let us understand the concept better through this example. For example, this first example we have. Do not pay your attention this side. Let us see this. Fx is equal to x square minus x minus 6, x minus 3, when x is not equal to 3, and equal to 5 when x equal to 3. Now we need to check the continuity of the function at x equal to 3, at the point x equal to 3. When it is given x not equal to 3, then it is for both x less than 3 and x greater than 3. So we find the limit here. Limit x tends to 3. X square minus x minus 6 by x minus 3. We know how to find limit. We find out the factors. It will come x minus 3, x plus 2 divided by x minus 3. X minus 3 cancels. So it is, we put the value now, since it is infinite value, 3 plus 2 equal to 5. So the limit of the function at x is equal to 3 or x tends to 3 is 5. And the functional value at 3, at x is equal to 3 is given 5. Therefore what? Therefore the function is continuous at 3 because limit of x tends to 3 fx is same as f of 3 and it is equal to 5, implies fx is continuous at x equal to 3. Is it okay? So this is how we check whether a function is continuous or not, by finding out the limit and the functional value. Now pay your attention or concentrate this side. Here we see that the function is defined at the point x equal to 1 and less than 1 or x greater than 1. Means the function is clearly defined for the values of x greater than 1 and less than 1. So when it is defined separately for less than and greater than, we use the concept of left hand limit and right hand limit. So left hand limit. Limit x at x equal to x tending to 1. So it is left hand limit means 1 minus fx. We put this value. Limit x tends to 1 to x square minus 3. That is 2 minus 3, that is minus 1. And right hand limit is limit x tends to 1 plus fx, that is equal to limit x tends to 1, 5, that is 5. So what do we notice? We notice that the left hand limit and right hand limit does not exist. Hence what? Hence the limit only does not exist. If the limit does not exist, then there is no question to compare with the functional value. Hence LHL not equal to RHL. Hence fx is discontinuous at x equal to 1. I suppose the concept is clear now, that how to check whether a function is continuous or discontinuous at a given point. Let us see one or two more examples, then I think your concept will be better. Now let us observe this particular function. Now we are supposed to check the continuity of the function, whether the function is continuous or not. What we notice, if I see the function carefully, the function fx is equal to x plus 2 if x is less than 0 and minus x plus 2 if x is greater than 0. What is missing? X equal to 0 is missing. That means the function is not defined at x equal to 0. So if the function is not defined at x is equal to 0, let us draw the graph. This is 0, this is 2 and this is minus 2. this is x-axis, this is y-axis. Now for values of x less than 0, x this side, we have say -1. If I put -1 plus 2 is 1. Alright. Now let us see this question. Find the values of a and b such that the function defined is continuous. Now since it is written continuous, we have to understand that the function is continuous for all real values of x. You have to find the value of this a and this b. The function is defined in 3 steps. Now, we see that the values of x is less than 2, it gives fx 5, and in between 2 and 10, it is ax plus b. So, what we notice is there are 2 numbers which are taken into granted for the sake of the function to define the function. So we take the point 2 and 10 as the critical points. Now since the function is continuous throughout, the function is also continuous at 2 and 10. We know that the function is continuous at all points, but we purposely take 2 and 10 because at this 2 and 10 the function is clearly defined. Now as the function is continuous at 2, then limit at 2 we will find. So left hand limit at 2 at x equal to 2. So limit x tends to 2 minus fx. This is less than 2, that is 5. And RHL at x equal to 2, that is limit x tends to 2 plus fx, that is limit x tends to 2 ax plus b, that is 2a plus b. As the function is continuous, LHL equal to RHL, and that is equal to, that means 5 is equal to 2a plus b. This is one equation we get. Also the function is continuous at 10. So LHL at x is equal to 10, that is limit x tends to 10 minus fx is equal to limit x tends to 10 ax plus b, that is equal to 10a plus b, and RHL at x is equal to 10, that is limit x tends to 10 plus fx more than 10, that means it is equal to 21. So what we get? 10a plus b equal to 21. This is the second equation. Is it okay? Now we solve 1 and 2. So we get 2a plus b equal to 5 and 10a plus b equal to 21. This cancels. Minus 8a equal to minus 16. So a is equal to 2 and b will be how much? A is 2, then 4, b is 1. The values of a and b are 2 and 1 when the function is continuous. I hope you have understood. Let us see the next example. Now, till now, we have been discussing only about algebraic function. Now, there is an important concept, that is all trigonometric functions are continuous in that domain of definition. Now, it is not possible for me to, in this small video, to explain for all trigonometric function its continuity. I have taken up only one function, say fx is equal to sin x. Fx is equal to sin x. Now, the domain of definition of the function f is R. Okay, the domain of definition are all real numbers. Now, let us take a point C belongs to the domain of definition. Then f of c is what? F of c is obviously sin c. Now, limit x tends to c, fx. Let x is equal to c plus h when h tends to 0. H tends to 0. So, limit h tends to 0 sin c plus h. In place of x we put c plus h. So, putting the formula of sin a plus b, limit h tends to 0 sin c cos h plus cos c sin h. Is it okay? Now, taking this is constant term, sin c is outside, limit h tends to 0 cos h plus limit, again cos c is a constant, so we will write cos c outside, cos c limit h tends to 0 sin h. So, cos 0 is 1 but sin 0 is 0. So, this is sin c into 1 plus 0. So, we have got limit x tends to c, f of x is sin c, and this is also fc, implies fx is continuous for all the values of x in the domain of the function fx. So, these were the examples that I could present before you in this short video. There are many more examples you need to practice, then you can be little bit confident about the chapter of continuity. If you have obviously doubts, surely you can comment in the comment box, and you can request for some more videos if you want. What are the types of questions you request before uploading it? If not, you please continue with the exercise and the problems that you have in your book. We also have the properties of continuity, which I shall discuss in my next video. Till then, keep studying and always try to do the sums from the examples of the book as well as from the exercise, and understand the concept properly, and then you move on with the problems. Then only I think the confidence will increase within you and you can do better in your exams. Do not forget to share, subscribe, like my videos, and obviously request your friends also to see the videos, and if they like, tell them to subscribe. Till then, see you again. Bye bye.